Hello again and welcome to the wonderful world of index laws. Okay, so for this tutorial, I'm going to teach you 7 index laws. There are more, but we are focusing only on 7. Okay, but before we do that, let us look at the anatomy of an index. Okay, what you see here below is an example of a number with an index. Okay, now what is an anatomy? Anatomy is the part what something is made of, and we're going to talk about the two parts that make up an index number. Okay, so at the bottom here, this is what we call the base. Okay, this is the base, this is the index. Now for you US people out there, we call that exponent. Here in Hong Kong, UK, we call it index. Now what this basically means is that, okay, we multiply the index, the base by itself, the number of times the index tells us to. Okay, so in this example, we multiply the base by itself how many times? 5 times, because the index is 5. So this really looks like 3 times 3 times 3 times 3 times 3. Okay? Please do not do this. This is not 3 times 5. This is wrong. This is not 3 times 5. This is not equal to 15. Okay? This is 3 times 3 times 3 times 3 times 3, which is equal to 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. Not 15. Okay? Please keep that in mind. That is one of the biggest mistakes students make. You do not multiply the base by the index. You multiply the base by itself, the number of times the index tells you to. So in this case, you multiply 3 by itself 5 times. 1, 2, 3, 4, 5. And you see the difference in the answers, 15 versus 243. That is a big difference, okay? So now let's go to index rule number 1. Okay, so in this one, let x represent the base, okay? Let x represent the base. Just a little algebra, nothing to worry about. This is just letters representing numbers, okay? Let A represent any number, B represent any number. So the first rule, okay, before we do that, what is this dot doing there? Okay, in algebra, we change the multiplication sign to dots or brackets. Why? Because if we use the multiplication sign, it looks very similar to the x variable. Okay, so that's why when you see the dot or a bracket, you know it's multiplication. Okay, so the first rule says when you are multiplying, okay, when multiplying indices, okay, you add the indices. Okay, when multiplying numbers with indices, you add the indices. So see, x to the a power times x to the b power equals x to the a plus b power. Let's give an example. So for example, I have 3 to the second power times 3 to the third power. That will be equal to 3 to the 2 plus 3 power, which is equal to 3 to the fifth power. Okay? Now take note. The bases need to be the same. See, the bases need to be the same. You cannot use any index law if the bases are different. Okay, so take note. Bases are the same. If you had 3 to the second power times 2 to the third power, you cannot use the index laws. Bases need to be the same. Okay, so index law number 1, when multiplying numbers, okay, sorry, put numbers with indices. When multiplying numbers with indices, you add the indices, okay, and the base remains the same. See, base remains the same. Index law number 2, okay, which says when dividing, okay, numbers with indices, the indices are subtracted. Okay, so when dividing, you subtract the indices. So x to the a power divided by x to the b power equals x to the a minus b power. Okay, so again, let's put an example. 4 to the 8th power divided by 4 to the 4th power equals 4 to the 8th minus 4, which is equal to 4 to the 4th power. Again, the base needs to be the same. You cannot do this if the bases are different, okay? And the indices are subtracted, okay? Now, what if you have this example? 4 to the 4th power divided by 4 to the 5th power. How is that going to be? Do you flip it? No. Same rule applies. 4 to the 4 minus 5, which will give you 4 to the power of negative 1. Okay? And we are going to do, there's an index law that tells you about that. That's index law number 4. Okay? So remember that. So let's go to the next one. Index law number 3. So this tells you that when a number with an index is raised to another index, okay, you multiply the indices. Okay, so look at this one. We have x to the power of a raised to the power of b. So what do? We multiply a and b, a times b. Okay, so if you have this example, a number with an index raised to another index, we multiply the indices. Okay, example, 5 to the 3rd power raised to the 2nd power gives you 5 to the 3 times 2 equals 5 to the 6th power. Okay? Now, what if we have 5 to the 3rd power to the negative 2 power? You can still do that. It's just a negative number. Remember, you did that worksheet on multiplying, dividing, adding, subtracting positive and negative integers. Same thing. So this will be 5 to the 3 times negative 2. And we know positive times negative will give you a negative answer. Okay? So, both are correct. Just follow the rules. Whether the numbers here, the indices are positive or negative, same. Okay? Now let's go to index law number 4. So now we have the negative index. Okay? Now let's look at that. Another example of a negative index. Another example of a negative index. Basically, a negative index just means that the answer is a fraction. That's it. It's just a fraction. Okay? So any number, okay, any base raised to a negative index is a fraction. And if you notice, this is negative, and once you make it into a fraction, the index is now positive. Okay? So let's look at the examples we have here. So this one, we can write it as 1 to the 4 to the first power. And as you will know later, there's an index rule. Any number raised to the power of 1 is itself. So the answer here is 1/4. Okay? Over here, it's going to be 1 over 5 to the 6th power. Notice the negative sign disappears when it becomes a fraction. Okay? So over here, same thing. If we have x to the negative 1, it's equal to 1 over x to the first power. And as you will know later, index law number 5, any base or number raised to the first power is itself. And that is why this will end up being 1 over x. Okay, so let's see, 8 to the negative 1 power would be 1 over 8 to the first power would be 1/8. Okay, which brings us to index law number 5. Any number raised to the first power is itself. Okay? Any number raised to the first power is itself. So basically, 5 million raised to the first power is still 5 million. 1,234,578 raised to the first power is still 1,234,578. Very simple index law number 5. Which brings us to index law number 6. Even more simple. Any number raised to the 0 power is equal to 1. That's it. So if I have 1,000,000, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 raised to the 0 power is 1. Okay? 157,289 raised to the 0 power is 1. Any number raised to the 0 power is 1. Okay? And the last index law, number 7, 1 raised to any power is still 1. Why? Because remember the first thing we said, index law number 1? Okay? If we have 1 raised to the 10th power, it's just 1 times 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 1, 6, 7, 8, 9 times 1. 1 times 1 is 1, 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 times 1 is 1. So it doesn't matter. 1 to the 1,000,000th power is still going to be equal to 1. Because 1 by itself is still 1. Okay? So those are the 7 index laws that you need in order to understand or to be able to do the worksheet on indices. Okay? It's very simple. Just be very familiar with the index law. To recap, okay? This is the base and this is the index. In order to use the index law, the base needs to be the same. Okay? Base needs to be the same. Index law number 1, when multiplying numbers with indices, same base, see x and x, add. When dividing, subtract. When raised to another index, multiply. When raised to a negative index, make it into a fraction and the negative sign disappears. When raised to the first power, is itself. Okay? When raised to the zero power, becomes 1. And 1 raised to any power is still 1. Okay? Bye-bye.